Okay, we're back to SBT. Let's look at the obstacle side of things now. So now I've got parameterized tests, table of obstacle commands. So when I move 4 times, starting at position 0, then I expect to have an obstacle, which is the O, capital O, 0:2 position, because I've got an obstacle at 0:3. So therefore I can never move to 0:3 facing north. I expect to be at 0:2 and facing north when I try and execute north movement to the north position 4 times. So how have I implemented this? So let's go to the direction class first of all. So the direction class has the short name, and the short name here, which is, and then the grid class has this case class called obstacle, which takes x coordinate and y coordinate, and the grid now takes a set collection, a Scala, a mutable set collection of obstacle. Initially it's initialized with an empty set. That's the default parameter initialized, and then I've got a function here which it sets a coordinate, x and y coordinate, and constructs a case class instant obstacle. And is this obstacle part of the set of obstacles? If it is, then we've encountered an obstacle. So that is obstructed here. Okay, so let's move you all down to here. Go back to the Scala class. In the parameterized move obstacle commands, I have the same. I should be hitting an obstacle because therefore I've created a rover of position 10, 10 with this set of obstacles. So this is all in line, instantiated at 0:3. Which matches what we expect in the test here, the parameterized table test. So I can go and execute this test and prove that it works. So if I scroll all the way down, therefore I've hit an obstacle and it is passing. Let's see, I did create, wanted to prove out creating a grid. So I'm able to create a grid, as you can see here, and it's because it's case classes, you get some nice formatted 2-string output. I can check that the grid is constructed correctly with the isObstructed method call, and so at 0:2 it's false, at 0:30 it should be false, but at position 3:2, which I constructed the grid of 7:7 with, then I should be obstructed. So let's go into the function itself, the move function, the execute function here. So as you know, everything is the same. I've got direction, enumeration type, and I'm using something called breakable here, which is from Scala util library. So what it does is adds like a DSL, domain specific language, breakables, syntactic sugar. So because Scala itself doesn't support break as in the language, so what we have is through implementation rise a try and then catch here, but you've got to include the breakable extension, which I have done, and you have this break function here that will throw the exception to get you out of the for loop. Kind of interesting, isn't it? What else is there? So what else? You've got the last x and the last y as a tuple, and so when we move the rover, we check, is that position of the grid obstructed or not? If it is obstructed, then we move it back to the previous recorded position, which is here, and then we add blockages are text. So O dot colon is what we have to report, as in the requirements. And there we've got a temporary variable called blockages, which is just an empty string. So if there is no blockages, then what gets reported down here in the string interpolation is just what the information that we had before: position, x coordinate, y coordinate, direction, short name. And that's all there is to it. Everything else is actually the same in this function, and that is how we implement obstacles. Good. So you know that the code works. So let's run it one final time for proof, because people sometimes need proof. What I would say then to finish up is this is perfectly fine. I've got the README here. I've got the SBT. So this should take a Scala engineer about an hour. A less cleverer or less experienced engineer, I would say about 2 hours. But as you can see, the test here is checking that you have ability in using parameterized tests. So if you were to write this in the long fashion, you probably would fail because there's too many functions. And remember, programming is what you can refactor, what you can reuse in a library. So if you use the ScalaTest parameterized test, you get the big thumbs up from me. The Rover class, breakable, is fine. You don't have to go fully functional on this. The use of case classes is mandatory for me. It shows that you have understanding of Scala, that you know there are default parameters and assignments. Yeah, there's a few things here. I could get rid of the brackets here if I wanted to and make it a bit more slicker. I would probably throw over the fence the direction if I was using Teams or a Zoom call. It's because of the trickiness of Scala 2, how to make a useful enumeration. It gets a lot simpler with Scala 3 enumerations. Then I will probably have to throw this over the fence to you during a test. Like I'm going to send you over Slack or something a direction. Please use this instead and see how you go. Because interviewing, it takes a lot out of the interviewer as well. So I just want to know, can you get to the end? Or how far along can you get to the end? Do you understand Scala? Do you use case classes? Do you understand test-driven development? Do you understand ScalaTest? So, and that's about it, really. Okay, that's it. I hope you had fun. Any questions? Find me on Twitter, LinkedIn, or just chuck me an email. I don't care. I bid you adieu and